Hey guys, welcome to another video. So this video we're gonna talking about gravity acceleration, okay, or the motion under gravity. Okay, so first thing we want to define is, well, if I have two things that weight differently, say if I have two objects that weight differently, right? One have a big mass, one have a small mass. If I drop them, which one landed on the ground first? Okay, so you probably learned it last year from year 11 is if we ignore air resistance, they're gonna fall exactly at the same speed going down, okay? Well, if there is air resistance considered, then the heavy object probably gonna fall a bit faster depending on the aerodynamics of these two things, okay? So, if I have this piece of paper and this, if I drop it, obviously the book is gonna fall faster, the paper is gonna have air resistance, right? But if I put them together, and then get rid of the air resistance for the paper by putting it on top of that, and then you can see they actually drop exactly at the same time. So how big is the acceleration? The acceleration is going to be a constant acceleration. Gravity acceleration equals to 9.8 meter per second squared. So last year you used 10, but this year you have to use 9.8, okay? All right, so and how do I use these? I use this with kinematic equations, okay? Say, I'll give you guys an example. Let's say, I'm going to throw a ball upwards, okay? And when I'm throwing the ball upwards, let's pretend that I started from the ground, okay? So I started from the ground, and I gave it an initial speed. I'm going to throw it at, say, pretty fast, okay? 15 meters per second, okay? And the question is going to ask you, say, well, how tall can this ball reach, okay? Because it's going to reach this height, and then it's going to start to fall down, right? Okay, sweet. Two questions. Well, one is going to be calculating the distance the ball can rise, and the other one is, well, maybe you can ask you, well, how long did it take for it to reach the top position, okay? All right, so over here, we have two important hidden information. One of the hidden information is, over here, there's actually a final speed. The final speed is going to equal to 0 meters per second. That's because when this thing is throwing up in the air, when it's reaching the top, the speed is 0. Because if it still has speed, it's going to keep going up. It's only when its speed becomes 0, and then it starts to fall down, right? Okay, so now we know this, we know acceleration. However, this acceleration is actually going to be a deceleration because when the ball is going up, the acceleration is going downward, trying to slow it down. So it's very important that we're going to put a negative sign over here at 9.8. Okay, if I don't put negative 9.8, then I'm going to be wrong. Okay, all right, and then I can go, okay, I know this, and I know this. So which equation do we use to find my answer? Well, I go to my kinematic equations. So, and then see which one we can find. Let's say the first one we're going to use is going to be using this equation. Okay, so, well, my final velocity is going to be 0, right? And then my initial velocity, I started at 15. And then plus, this acceleration is going to be negative 9.8, and the time is t. Okay, great. First try already succeeded. I can find the time of this process. Okay, so negative 15 is going to equal to negative 9.8 t. What does t equal to? Then equals to a negative 15 divided by negative 9.8. Okay, so put that into the equation. (1.53 seconds). Okay, this is second, not 5. Okay, so now we know the time. I want to calculate distance, and then have a look of another equation. In fact, it does not matter what equation you use. There are plenty of them. Let's say VIT plus half AT squared. Let's say we use this equation. Okay, what is the height it's going to rise to? Initial speed 15. Time I've calculated 1.53 plus half acceleration 9.8. Weight, this is deceleration, so it must be a negative 9.8. Okay, negative 9.8, and then times a t squared times 1.53 squared. Okay, and then I can put this in my calculator. that becomes 22.95 minus 9.8 times 0.5 times 1.53 times 1.53, 11.47. Okay, and then I can, so 8 minus 4, and then 11.48. I'm gonna give it 11.5 meter. So that's how far this thing's gonna rise. Okay, so all of this question is going to be the same. This is actually the difficult one because it's going to be a deceleration situation. If it's an accelerate situation, then you just use accelerate. If it's slowing down, and then there's an initial speed. If there's an initial speed, you're going to put the initial speed into the equation over here. Okay, so there are 2 examples I give you in the notes, and then there are 2 questions on your back of the book you can try. So try to use that and have a go. And if there's any question, send me an email, and we'll see you in the next video. Bye.